Okay, 3-8 more. Why does that look so terrible? More, that even looks worse. More quadratic functions in vertex form. By the way, if this is the first video you're catching of mine, which is why I always tell you this, you can always find us at www.nkinfinity.com. We're also at, as it says on the bottom, algebra2commoncore.com. You can find us there as well. All of these videos are nice and neatly organized. If you're a teacher, I've got an opportunity for you to get all of this stuff at a reasonable rate. If you have any questions, there's places to leave comments and questions. Anyway, we are going to start 3-8. It's a little bit of a continuation of some things that we did yesterday. Thank goodness. My name for the next however long this takes. I know, it takes infinitely long because it's math. Anyway, we'll be rolling and rocking for the next half hour or so. So let's see what we can do. The first thing we're going to do is try to match up a graph with a parabola. Thinking about all those little transformations that we talked about. Actually, we've been talking about them for a while now. So let's see. First thing we're going to do is we're going to circle all of the parabolas that open or are concave up. They're going to open up. That's going to open up. And that's going to open up. And that's going to open up. Okay. This one, this first one, has a vertex that is, do you know, +4, 4. So we need the one that find the one that opens up that has a vertex 4, 4. And there it is right there, number 5. Is that f of x? F of x, right there. Keeps going away from me. F of x. All right, we did that one. Let's check this one. This one has a vertex of +1, +2. So let's go find that one. It's opening up +1, +2. It's right there. There is h of x. And finally, this one just slides. It's minus, but it slides right fine, but not up or down, and that would be right here, m of x. Okay. The other three all open concave down. So let's just take these one by one. J of x has a vertex that's -7, up 6. So I need one that goes down over 7 and up 6. That looks like this one. So this would be J of x. This one goes right 5, down 1, and it's going down. So right 5 and down 1. That would be this one. Let me guess. That's G of x. I'm guessing that's G of x. Yes, and the last one, it just goes up 10 units, doesn't go left or right at all, and comes down. So this would be, I think it was K of x, right? Is that K of x? That's Krause of x. Oh my God, that's my favorite one right there. Anyway, all right. So let's do a little review from yesterday. This is, well, by the way, this all should be the warm-up. Yep, this is all the warm-up. Page 1 is all the warm-up. So remember the first step for completing the square. We're going to bring the 30 over to the other side. So 2x squared plus 16x equals +30. We need to get rid of the leading coefficient 2, divide by 2, divide by 2, divide by 2, and I get x squared plus 8x plus square equals 15 plus square. So we're almost done. Got all the hard part done. Nah, not quite. What is half of this? Because that's what goes in these parentheses. So that's x plus 4. 4 squared is 16. And 15 plus 16 is 31. Oh, man, I gave you an easy one. That's ridiculous. So don't forget, that's next step is to take the square root. When you take the square root, you put a plus or minus. So I get x plus 4 equals plus or minus the square root of 31. Pop that 4 over, and I get x equals -4 plus or minus the square root of 31. All right, I'm going to pause for a second, and I'll be right back. All right, that wasn't too bad. Let's keep going. Let's see what we got. Oh, come on. Wake up, computer. All right, so let's talk about transformations real quick, and then we'll get in the meat of today, and then we'll be done. Yay. So transformations on the quadratic function. So if I gave you the parent function, this is the parent function x squared, and I said all we're going to do is do f of x minus 3. What is the transformation? It is a translation down 3 units. So on the original f of x, our vertex is 0, 0. But if we're going to go down 3, my new vertex is 0, -3. And remember, the axis of symmetry is always x equals the x value of the vertex. In this case, 0. All righty, let's keep going. Not sure why that's there still. So our parent function is right here. And all we're doing is putting that 1/4. We're doing 1/4 of f of x. So remember, that's a dilation. Now you should be able to tell me that it's going to make it wider. It's a dilation of 1/4. And by 1/4, instead of it going up like this, it's going to make it over, it's going to make it wider. Wider. I think you get it. But we're not changing the vertex. So the vertex is still 0, 0, and my axis of symmetry is still x equals 0. All right, what we did here is, that's right, we put a negative out front. And a negative out front is a reflection in the x-axis. But no other transformation took place. So the vertex not moving, it's still 0, 0, and my axis of symmetry is still x equals 0. So now I'm going to change things up a little bit. I'm taking f of x, which was just x squared, and I'm putting a -4 inside the parentheses. If it's inside the parentheses, that's going to be a translation left or right, but backwards from what you normally would think. Okay, so in this case, it's a -4, so it's a translation to the right 4 units. So normally, my vertex would be right here at the origin, and it would be going up, but we're going to move to the right 4. 1, 2, 3, 4. So, oops, 1, 2, 3, 4. So my new vertex should be not 0, 0, but 0. Excuse me, not 0, 0, but 4, 0. And therefore, my new axis of symmetry is x equals 4. All right, so this one we did all kinds of crazy stuff. We did it all. We did all of it. We went to town on this baby. So the negative is a reflection in the x-axis. The 3 is a dilation and should make it steeper. So dilation 3. It moves to the left 2 and up 4. So this is and 4. And these are translations. You should be able to use the appropriate math word. They are translations. So it's a reflection, a dilation, and 2 translations, or it's a slide. So my new vertex is -2, +4. And my new axis of symmetry is x equals -2. All righty. I'm going to pause now that I did that whole page. So this is what we're here to talk about. Some cool stuff coming. All right. So our goal today, and I kind of prefaced this yesterday by telling you that we're going to talk about it. Our goal today is to take a quadratic in standard form, ax squared plus bx plus c, when you don't really know and you can't really graph this that well, to a form that's really, really, really easy to graph and see what's going on. We can see if it's where it's shifted, is it up, is it down, is it left, is it right, so on and so forth. So that's our goal today. Our goal is to write this sucker. Hold on, I'm a little confused by something. Give me a second. Okay, I had to black out that whatever that equation was. I'm not even sure where it is, but it might actually be the answer. I don't even remember. But we're going to take a look at this. So here's what we got. We've got y equals x squared minus 8x plus 17. So here's how we're going to handle it. We're going to add, in order to balance equations, we're going to add the same thing to two sides. So we're going to take half the b term, so that's negative 8 over 2, which is negative 4, and we're going to square it, and we get 16. So we're going to add 16 to both sides. So y plus 16 is equal to x squared minus 8x plus 16 plus 17. We're going to factor this, just this part of it. So I get y plus 16 equals x minus 4 squared plus 17. Okay? Now I want to solve for y. So I'll subtract 16, and I get y equals x minus 4 squared plus 1. And I believe that's what this is. I don't know why it was here, but there it is. So my vertex is 4, 1. There it is. That's it. I know it's a parabola going up. I know it moved to the right 4. It moved up 1, and it's going up at a normal rate. All right, so solve by completing the square. So, all right, so you still need to be able to get rid of this 3 here. So we still need a equal to 1. So what we're going to do is we're going to write this as okay, we're back. So we still need to get a equal to 1. I just said that. So what we're going to do is divide this side by 3. But you can't divide one side by 3 and not divide the other side by 3. All right, so what we have here is, now it's going to get a little funky. F of x divided by 3 is equal to x squared plus 12x plus 14. We're going to now that's the first step. So now we're going to follow these steps. Step 1, we're going to add half the b term, so that's 12 divided by 2, which is 6. So we're going to add 36 to both sides. So we're going to do f of x over 3 is plus 36 is equal to x squared plus 12x plus 36. Now we're going to put that 36 here so we still continue to create that perfect square trinomial plus 14. All right, so what am I going to do now? I'm going to factor this baby. So I'm going to leave this the way it is. You'll see how we get rid of it in a second. So this is x plus 6 squared plus 14. Now we're going to bring the 36 over. Subtract 36. I'm going to subtract 36. So I get f of x over 3 is equal to x plus 6 squared minus 22. We're almost done. I just got to get rid of that 3. So what I'm going to do is I'm going to multiply this side by 3, and I'll multiply this side by 3. So I get f of x equals 3x plus 6 squared minus 66. Identify the vertex, -6, -66. Remember, it comes out opposite. So this has a dilation of 3. Well, we knew that because we go back to the original. The original had a dilation of 3. The vertex is -6, 66. It's opening upwards. There we go. All right, so they're not really going to get that crazy funky. I really want to be able to just do it on the simple matter. So let's try a simple one. Let me pause it. I'll be back. So sometimes I wonder why I tell you I'm going to be back, because I don't need to tell you. So here we're going to go through the steps. Let me blow these babies up. No, I'm not blowing anything up. I'm just making them bigger. All right, there we go. So step 1, we're going to add half the middle term, half the b term, to both sides, squared. So I'm going to add 25 to both sides. A half of -10 is -5. -5 squared is 25. So x squared minus 10x, we're going to put it right here, plus 25 plus 1. We're going to factor this. So I get y plus 25 is equal to x minus 5 squared plus 1. And finally, we're just going to bring the 25 over, so we'll subtract 25, and I get y equals x minus 5 squared plus minus 24. So my new vertex is 5, negative 24. Not too bad, right? Not so bad. All right, let's do this one. So we're going to take half the middle term. Half of this is negative 12, and negative 12 squared is 144. So we're going to say, OK, we're going to add 144 to both sides. X squared minus 24x plus 144 plus 10. So we're adding the same thing to both sides. Remember, that's how you balance an equation. You do the same thing to both sides. All right, so this is going to be factored. That's a perfect square trinomial. It is x minus 12 squared plus 10 is equal to g of x plus 144. Now we just solve for g of x. We subtract the 144. I know they're crazy numbers. You'd never have to graph these like in class, but you can certainly get the quadratic the same. And I end up with it x minus 12 squared minus 134. Now, just for fun, though, I want to see if this is right. I have no idea if this is right. You look at it, you're like, I don't know why I went through the steps. How do I know if it's right? All right, so let's take a look. Let's go to graph mode. And we're going to graph the original. The original was x squared minus 24x plus 10. So x squared minus 24x. Oh, I think I got, that's a negative. Minus 24x plus 10. All right, there you go. That's what it looks like. I can't see it. I mean, I can zoom out. Actually, what you want to do is go to Menu, Window, and then just choose Zoom Fit. Even that's not good. Ugh. But whatever. It really doesn't matter as long as you can see part of it. And I'll tell you why. If I want to go, I'm going to hit the Tab button, and I'm going to graph the thing we just created, which was x minus 12 parentheses squared minus 134. That's what I came up with. I mean, I don't know if it's right, but watch this. Click. Now watch what happens to the blue line. The red line went right over the top of it. And that's how you know if you got the right equation, because it will map the new one right over the old one. And you know you have it right then. So that's a nice little test to see if you're accurate. Because most people look at this and are like, well, maybe it's right. How do I know? Those don't even look anything alike, but they are. Okay? All right, we got a couple more. Let's see what we got. So we're going to take half the middle, which is 7, and square it to both sides. So plus 49, square it. So x squared plus 14x plus 49 plus 11. Now don't put these together, because this creates our perfect square trinomial, which is what we want. That's the thing we're going to factor. Creating that perfect square trinomial is the thing we're looking for. So it's x plus 7 squared plus 11. And then we've got h of x plus 49. We'll subtract the 49. And we get h of x equals x plus 7 squared minus, what is that, minus 38? Not sure if I did that math right. Let's check it. Let's check it. We'll Doc B this sucker. Doc B, get off my screen. Go back to graph mode. And the original was x squared plus 14x, x squared plus 14x plus 11. Awkward graph. By the way, it's going to be down here. I know my vertex. If my vertex is right, it's negative 7, negative 38. So let me go into Menu, Window, and Zoom, and let's do my box setting. So how about we go negative 20 to do, I don't know, 0. Let's go 5. Doesn't matter. And then let's go negative 50 and 50. Now I can see it. So now I'm going to hit tab, and I'm going to type that in. X plus 7 squared minus 38. So parentheses, x plus 7 parentheses squared minus 38. Now let's see if it should map right over the old one if it's right. There it is. So you know you got it right if you did that. Okay, that'll be the last time I check it. I forgot to tell you the vertex on each of these. This one is negative 7, negative 38. Did I do it on this one? I did it on this one, but I don't think I did it on this one. This one, the vertex is 12, comma, negative 134. Remember, this comes out opposite. This is what it is. All right. Is this the last problem? I don't think this is the last problem. All right, let's go. So half the middle is negative 1, and negative 1 squared is just 1. So y plus 1 is equal to x squared minus 2x plus 1 plus 6. Remember, we want to create this perfect square trinomial. So we have y plus 1 is equal to x minus 1 squared plus 6. All right, now we're going to subtract 1, and I get y equals x minus 1 squared plus 5. And my vertex is positive 1, 5. Catching! All right. If you ever want to mess with your parents, show them this page. Be like, Mom, you don't even know how hard math is. Look at this. I got to do completing the square on this generic form or this center radius form, or create it from general form to center radius form of a circle. And look at this. Hey, oh my gosh, it's so difficult. Relax. Relax. Circles are actually easier than the if you thought the last thing we just did wasn't too bad, these are really, really, really simple. Really simple. So we're going to take an equation that's written in general form. X squared plus y squared minus 4x plus 6y plus 4 equal to 0. And we're going to put it in center radius. We're going to put it in center radius form, and then we're going to tell you what the center is and what the radius is. Because the center, if you go back to looking at this, remember, the center, if I take that h out, it's positive h. If I take that k out, that should be minus. That should be minus, is k. And the radius is just equal to radius. So here's how it works. You're going to move the constant over to the other side. Does it sound like completing a square? When I do, no, just kidding. So we're going to move the constant over to the other side. And then when we rewrite it, we're going to group the x's together, and we're going to group the y's together. And we're going to write it in a very special form. You ready for the special form? All right, so we're going to write x squared minus 4x plus, and you guessed it, completing the square. Why else would we be doing this here? Plus y squared plus 6y plus, you guessed it, completing the square, equals, now we brought the 4 over, so that makes it negative 4. But notice I added a box here and a box here. Well, if I add 2 boxes on this side, I got to add 2 boxes on this side in order to keep the equations balanced. Now, same exact steps as before. We're going to take half of this, square it, and put it in there. But remember, it goes in these parentheses. So x, half of negative 4 is negative 2 squared. And then if I square negative 2, I get 4. So I need to put a 4 there. So far, so good. Plus, we're going to do half of this and square it. But remember, that half goes in here. Half of 6 is positive 3. 3 squared is 9. But if I put a 9 there, I got to put a 9 there. And then I just clean up this side. Negative 4 plus 9 is 9. I'm done. That's it. What is my center? My center is positive 2, negative 3. And my radius is equal to, remember, this is radius squared. So my radius is just 3. What do you think? Not too bad, right? Circles aren't bad at all. You can handle them, all right? So we're going to do the same thing. Group the x's with a box. Group the y's with a box. Bring the constant over to the other side, and since you put 2 boxes on the left, you got to put 2 boxes on the right. So we're going to group the x's. X squared plus 2x plus squared plus y squared minus 8y plus squared. This is like completing the square, completing the square. You're doing it twice. Is equal to -1, but I have 2 boxes. I have 2 new boxes on the left, so I got to put 2 new boxes or squares on the right. All right. Half the middle, x plus 1. Half of this is 1. 1 squared is 1. Don't forget to put it over here. Over here. Plus, now a lot of kids forget this plus sign. Don't forget this plus sign. Oh, and a lot of kids forget those squares too, like I almost did. Half of -8 is -4. -4 squared is 16. 16 and 16. If I add all this up over there, it just becomes 16. And I'm done. That's it. My radius, or my center, is -1, 4. Opposite. Opposite. And my radius is equal to, remember, this is radius squared, so my radius is equal to 4. Almost done. Wait, that might have been the last problem. Oh, no, we got a whole other page of problems. So this is your turn to try. Right now, press pause. You don't want to listen to me for the next 10 minutes anyway. Press pause. Come back, see how you did, because I'm going to be just going through these rather quickly, okay, because they're not that difficult. So press pause. Did you get an opportunity to get that crazy face? I hope so. Welcome back. So x squared minus 2x plus box square plus y squared plus 4y plus square equals, oh my God, I'm running out of room, -1 plus square plus square. I'm going to have to write smaller. I'll write smaller over here. So half of that is 1, -1. -1 squared is 1 and 1. Plus y plus 2 squared. Half of this is 2. 2 squared is 4. 4. And this equals 4. So my center is 1, -2, and my radius is 2. 13. Let's put the x's together. X squared minus 4x plus square plus y squared minus plus 6y plus square. The 4 goes to the other side, so it's -4 plus square plus square. Half of this goes here, so x minus 2 squared. 2 squared is 4. Yes, oftentimes these cancel and leave you a perfect square. Sometimes it doesn't and you have to simplify, but that's okay. Plus, don't forget the plus, y, and then half of this is plus 3. 3 squared is 9, so 9. And so the whole right side becomes 9. My center is 2, comma, -3, and my radius is equal to 3. 2 left. Go back to blue. So x squared plus 2x plus square plus y squared minus 8y plus square equals -1 plus square. Completing the square. Oh my God, so much fun. So blank blank squared. So what's half of 2? Half of 2 is +1. +1 squared is 1. 1 and 1. Plus y minus, what's half of -8? -8 is 4. -4 squared is 16, but if I add 16 to the left, I add 16 to the right. And the whole right side just becomes 16. So my center is -1, +4. Don't forget, big steps there. That when those numbers come out of the parentheses, they come out with a change in sign, and my radius is equal to 4. Now, if you've been copying everything I've been doing for the last couple of minutes, stop the video right now and do this one on your own. Because if you can't do this one on your own, erase everything you did and start over, because you should be able to do these on your own by now. I'm doing it we're going to dark blue. So x squared minus 10x plus square plus y squared minus 6y plus square equals negative 18 plus square plus square. So if you couldn't figure out the radius on this one, it's fine. Here, half of negative 10 is negative 5. Negative 5 squared is 25. So I'll put a 25 there. Plus half of negative 6 is negative 3. Negative 3, oh, I forgot the squared. That's a big mistake. Negative 3 squared is positive 9. Positive 9. So now I got to add all this up. Let's see. 25 minus 18 is 7. 7 plus 6, 7 plus 9 is 16. Okay, so my center is 5, 3, and my radius is 4. Now, one last thing I want to share with you, if you have the TI Inspire. If you don't have it, I guess you can stop right now. But if you have the TI Inspire, you can put things in your calculator. So let's say we're going to put in well, I'm going to verify that I got this right. So I'm going to do this one over here on the left. Try to do this one here on the left. So I'm going to go over to my calculator, Doc B, go back into graph mode. What I need to do is bring this to the left and bring this up. And I want to check this left one. So what I'm going to do is I want to see if I got it right. So I'm going to type the original in. So I'm going to go into menu. I'm going to go into graph, and I'm going to graph an equation, and I'm going to graph a circle. Now, if you get here, you got center radius form, and you have standard form. I'm going to do standard form first. So standard form was, that's a 1, and so is the y. The x value was a 2. Now, notice they got pluses and all that stuff, but I'm going to put, this is negative 8y, so I've got to put in negative 8 here and 1. So this hopefully will graph a circle. There it is. But I can also graph the circle in center radius form. So I'm going to go into menu, graph entry, equation, circle, and my two options are center form and center radius form or standard form. Now we're going to do center radius form. So my center was negative 1. You got to be careful. Notice our x value is negative 1, so I got to put in negative 1 here. And my y value was plus 4. And my radius is 4. And you see how it just right on top of it? Right on top of it. So I know that I got it right. Now that's a nice little form. I've given you the directions on how to do that. They're in the paper. I'm not going to go through too many of them. But that's an awesome way to see, do I have the right answer? Did I do completing the square correctly? Okay, kids, that's it. We are done with 3.8. Oh my God, so exciting. See you at 3.9. And 3.9 is kind of cool, but a lot of work. So good luck, kids.